Okay, now we're going to do a problem from top to bottom. And we're just going to go straight to, we're going to use the limit process. So we make the decisions on this one. Here's our graph, x squared plus 1, from 1 to 3. So I'm going to go with a regular partition. So my delta x will be 3 minus 1 over n, which is 2 over n. And it seemed like the right side, taking the c sub i's from the right side of each rectangle, seemed like that was algebraically easier in the last problem. So I'm going to try that again on this one. So c sub I, this will be right side c sub I. Now that would, according to this curve, that would necessarily give us an upper sum, and they'd be circumscribed. The curve is circumscribed by the rectangles. So c sub I, we'll start off, we want it to be a plus, we want I times delta x. Okay. In this case, that is going to be 1 plus 2i over n. Okay. So that would be the right side now. Now, when you do this, make sure that it gives you what you want. Notice when I is 1, I will start at 1, and then I'll add 1 increment of delta x. And that would put me at my next edge here, the right side of the first triangle. And if I added 2 of those, I'd be at the right side of the second triangle. So this does give me what I want. And notice if when I is equal to n, what happens? You'll get 2n over n, which is 1, right? So we're going to end up at that 2n over n, which is 2, sorry. So we're going to end up with 1 plus 2 is 3. So we will get to that, finally, to that right side, the last rectangle. And okay, so now we'll just go ahead and form our sum. F of c sub I delta x from 1 to n. And let's go ahead and put them in. I equals 1 through n. We want x squared plus 1, so it'll just be a 1 plus 2i over n squared plus a 1. And don't forget the delta x, which is 2 over n. So we're going to do a little bit of work with this thing here before we can find this sum. Looks like I'll pull out that 2 over n because I don't need that in there. This will be a 1 plus 4i over n plus 4i squared over n squared plus 1. Yeah. So it's 2 over n. Summation I equals 1 to n. And then we have, looks like a 2. And there's not much else we can do with these. 4i over n and 4i squared over n squared. Okay, let's take this over here now. We have a 2 over n. Now I'm going to open these up into separate sums. So we have the sum of 2, which that's this one, and then you'll have 4 over n, sum of I, that's the middle term, and then you'll have 4 over n squared, sum of I squared. So that's 2 over n. Sum of 2 is just 2n. 4 over n, sum of I, that's nn plus 1 over 2. And then this one over here, that I squared, remember that was n plus 1, 2n plus 1 over 6. Okay, now let's go ahead and expand by multiplying by that 2 over n. That's going to give us a 4 plus this case, we'll have a 4. Looks like n plus 1 over n, like that. N's cancel, 2's cancel. And then this last one looks like it's just going to be, we've got 2 with an n plus 1, like that, and 2n plus 1. And let's see. Is that right? With the 2, well, it's actually a 4, isn't it? That's a 4, because it's 8 over 6, which is 4 over 3. And you still have n squared underneath here. Okay, so far that's it. Now, remember that is our, in our case, that was a upper sum. And now you're going to take that limit. So I'm going to take the limit here. I'm going to get a 4 plus another 4, this one. And this one is going to give me 8/3, isn't it? So that looks like 8 2/3, like that. Yeah, 6. Oh, wait a minute. Yeah, 3 to 8 is 2. It's 10. 2/3. Okay. So that's our answer, 10 2/3.